Hello, I'm Mrs. J, and welcome to my math class. Today we're going to cover section 2.3, solving systems of equations. And there's a few different ways you can do that. Looking at these, the first way we're going to look at is substitution. And it's just that. You take one equation and you substitute it into the other equation. This one's used a lot when you have it solved for one variable. Notice this is solved for x. So we can take this and substitute it in for x. So instead of x, we have 3 times 5y plus 12 plus 4 equals 4y and negative 2. So you're taking that and plugging it in here. This was my x. Then follow your rules. Distribute the 3. 15y plus 36 plus 4y equals a negative 2. Combine like terms. 19y plus 36 equals a negative 2. Getting y by itself, subtract the 36. 19y equals a negative 6, 7, 8, 38. And divide by 19. Y equals a negative 2. Now you need to go back and plug it into one of the two equations and find the x value. This one's already solved for x. Plug it in this one. So we know x equals 5 times y, which is negative 2, plus 12. So we get a negative 10 plus 12, or 2. So our answer is 2, negative 2. Let's try one more. Notice this one is solved for y. So then we can take this and plug it in for y. So we have 2x minus 3 times 5x minus 18 equals 2. So we just plugged it in where the y was. Distribute the negative 3 minus 15x plus 3 times 18 is, I'm not going to do that in my head, it's too late at night, 54. And negative negative is a positive. 54 equals 2. Combine like terms, these two. Give you a negative 13x plus 54 equals 2. Subtract the 54. And 52 divided by 13, that's a negative 13. X equals a positive 4. Now we need to find y. You can use either equation, but this is already solved for y, so plug it into this one. Y equals 5 times 4 minus 18. 20 minus 18 is 2. So our answer is 4, 2. So that would be substitution, because you're taking one equation and substituting into another. Another one is called elimination. In elimination, you want to add down and have one of the variables, x or y, cancel. So notice this one's a 2x. If this was a negative 2x, when we add down, it would drop. So we can multiply that top equation by a negative 2. Negative 2 times x is a negative 2x. Negative 2 times the 3y is a negative 6y. Negative 2 times 5 equals a negative 10. And this one we're not going to change. And that is a 4, I think. Yeah. Okay, notice now the x's cancel when I add down. And I have a negative 2y equals a negative 2. Divide by the negative 2, and y equals a negative 1. Or, sorry, positive 1. Hold on 1 second. Sorry about that. So we get a positive 1. And when you have the positive 1, now notice neither one of these is solved for y. So it's a little bit more work, or solved for x. But you can plug it into either one. I'll use the top one. Always go back to the original. So we have x plus 3y equals 5. I'm going to use this one. So we take the 1 and we plug it in. X plus 3 times 1 equals 5. X plus 3 equals 5. Subtract the 3, and x equals 2. So we got, for our answer, 2, 1. It's another way of solving. Depending on how your equation is, that's how you decide which one to use. In the other ones, it was solved for a variable, it was easier to substitute it in. This one, it wasn't solved for a variable, it was easier to use elimination. If we look at the next one, for this one, we'd have to, a common denominator, you could think a common denominator, we'd need a 20. 1 positive 20, 1 negative 20 for the x's to drop out. So we'd have to multiply the top by 5 and the bottom by a negative 4. But notice in this one, they're already opposite signs. And I only need to multiply the top by a 2. I'll get a negative 6, and when I add, they'll cancel. So I need to take the top and multiply by negative 2. We get negative 8x plus 6y equals a positive 26. We're not going to change the other one. And when we add down, we get a negative 3x. And somehow I lost, oh, we don't want the negative. I'm sorry. Because we already have a negative. Notice this is already negative and this one's positive, so use a positive 2. And always do these in pencil because you can't find your mistakes. You need to erase and start over. 8x minus 6y equals a negative 26. On the bottom, we're not changing. Add down 13x equals, the y's drop. Subtracting, we get a negative 13. Divide by 13. And x equals a negative 1. We still need to find y. You can use either equation. I recommend staying with positives, but you can use either one. 5x plus 6y equals 13. I know x is a negative 1. 5 times negative 1 is a negative 5. Add it to the other side. And divide by 6. So our answer is x first, negative 1, 3. So that's how you would use a few that, I don't know why that happened. Okay, that will not work. there's special cases. I shouldn't say won't work. But let's solve them and then we'll see. So if we look at these two, this one, notice the x and y is on this side, but this one is not. But if we divide this one by -2, we could use substitution. So I would take this one and divide by -2. Remember, you have to divide everything by that, though. So we have a negative y, no, negative 2y, a positive 4 equals x. So then we can take and substitute in for x. We can take this and plug it in here. So since this was already had x by itself, I just divided by the -2. Then I can substitute. So I have 3 times -2y plus 4, plugging that in for x, plus 6y equals 12. Then distribute your 3. -6y plus 12 plus 6y equals 12. Got a lot of 6's and 12's. Notice the 6y's cancel. They leave a true statement. There's infinitely many solutions. Because they are the same line. So there are infinitely many solutions since they're the same line. If you have a true statement, 12 equals 12. Now on this one, notice if we multiply, we can get the 6's to drop out if we multiply this 3 by a -2, because then we'd have a -6. So I'm going to rewrite the first equation because I don't have enough room over here. 6x minus 9y equals 12. Now when I multiply by the -2, I get a -6x, a plus 9y equal to a positive 12. So this drops out and this drops out and leaves 0 equal to 24, which is not true. There's no solution. The reason there's no solution is the lines are parallel. That means they never intersect. So they're parallel. Let's try a couple stored problems. Oh, I did. Oh, guess we can do that one first. No. Okay. Sue chooses one money market that pays 6.2% and a mutual fund that has more risk but averages 9.2% per year. She has 300,000 invest. She would like to average 7.6% per year with a minimum risk. How much should she invest in each? Okay, now you want to notice we're talking about two different things. One, we're talking about percents, and the other one, we're talking about the total amount of money she's going to invest. So if we take X and let it be the amount invested at 6.2%, and let Y be amount invested at the riskier one, which was 9.2%. And the total we're investing is $300,000. So if this is the money she's putting into both, the two together need to be $300,000. And we know we're getting, for the money, we're getting 6.2 of this one. When you're using equations and you're plugging these in, remember they need to be the rate and not the percent. So the 6.2% goes with x. So 0.062x plus 0.092y equals, and she wants to get 7.6, which is 0.076 times the 30,000. So we have x plus y equals 300,000. And the other one's 0.062x plus 0.092y equals, and we need to multiply those together. And when you multiply them together, you get, I thought I multiplied them already. .076 times 2280. Now to solve it, it depends if you want to use elimination or substitution. If you're going to use substitution, you would solve one of these for x or y and then plug them in. But we could multiply all of them by this decimal and a negative of it, because if we multiply by negative 0.062, then the x will drop out. So we have negative 0.062x minus 0.062y equals 0.062 times, and I don't have enough zeros here. It was 300,000. Did I write it? This is probably one more zero. Careful, this should be 22,800. I lost a zero. So 0.062 times 300,000. 300,000. 18600. And it is negative. This one we're not going to change. But notice when you add down, the x's drop out. And then 0.092 minus 0.062. Oh, I could have done that. 0.03. 0.03y equals 22,800 minus 18,600 is 4,200. And then divide by the decimal. And we get y equals 140,000. But what does that mean? Well, if you didn't write these, you may not remember what was what. But y was the amount invested at 9.2%. So 140,000 is invested at 9.2%. How do I find y? Or x, we know y. Plug it in. We know that x plus y has to equal 300,000. So x plus 140,000. We just need to subtract the 140. 160. So if she invests 140,000 in this one and 160 in this one, she should yield her 7.6% that she wants. Let's try another one. A retail chain will buy 800 TVs if the priced at 350 each, and 1,200 if it's priced as 300 each. A wholesaler will supply 700 TVs at 280 each and 1,400 at 385. Assuming supply and demand are linear, find and explain the market equilibrium point. Well, to find that, you need to find both equations. And they gave us a point for each. So we have our demand is 800 TVs for 350 or 1,200 TVs for 300. And so we can find our demand equation using these 2 points. First, you find your slope, change in y, 300 minus 350, over the change in x, 1,200 minus 800, equals negative 0.125 when I plug that in the calculator. And then y minus y1, use the 300, equals our slope times x minus 1,200. So the equations, m equals y minus y2 over x1 minus x2. And this is y minus y1 equals m times x minus x1, in case you need a little refresher. But those are what I'm using. And distribute y minus 300 equals negative 0.125x plus times 0.125, 150. And then we're going to add the 3 to the other side, 300. Now you do the same thing for the supply. The supply, a wholesaler will supply 7 TVs at 280. And 1,400 at 385. So the first thing we find is our slope. 385 minus 280 over 1,400 minus 700. If you subtract those, you get 0.15 or 1500ths. So that's our slope. Y minus, use this one's smaller. Y minus 700. You can use either one. When you solve it for y, it will still give you the same value. 0.15 times x minus x, y. Y minus 280 equals x minus 700. Distributing the 1500th, we get 700 times 0.15 gives us 105. And then we're going to add the 280 to the other side. Which gives us 175. So that would be our two equations. This is our supply and our demand. We want to find when they are at an equilibrium. And we have an equilibrium when supply and demand are equal. Well, they're both solved for y. So we can just set them equal. I'm going to run out of space, so I'm just getting another sheet. When we set them equal, 0.125x plus 450 equals this. I'm going to add this to the other side. Leaving 450 equals, combining these, 0.12. And then I'm going to subtract the 175 to the other side, which gives me 275. Trying to get x by itself, divide by the decimal, which gives us, I think, 1,000. Yeah. So x is 1,000. Now remember, x was the number of TVs. So that would be TVs. To find the y value, the equilibrium price, we plug that into either one of the two equations. I'm going to use this one since it's showing. So y equals 0.15 times the 1,000 plus 175, which gives us 325. When the price is $325, the number of TVs demand equals the number supply which is 1,000 TVs. So 1,000 televisions will give us our supply and demand equal. and the price I'd need to sell them for is $325. Okay. Two more. A jewelry maker has total revenue, R of X equals 89.75X, and cost 23.5X plus 1,192.5. Find the break, it should say even. Find the break-even quantity. You break even when your revenue equals your cost. So the break even, and usually it's just the quantity that you're looking for. Your break even quantity is when your revenue equals your cost. So you want to set them equal to each other and solve. So this is our revenue, 89.75X equals our cost, 23.50 plus 1192.5. Subtract this to the other side. We get 66.25. And then we're trying to get X by itself, so we divide. So X equals 1192.5 divided by 66.25. 18. X was the quantity of jewelry. The jewelry maker has a total revenue of this. Yeah. So X was just, I didn't write it. So when the break-even quantity is 18 units. So you have to sell 18 units before you can break even. So you haven't made any money until you sell those 18. Yeah, that's all that one asked. The demand for a clock radio is given by P plus 2Q equals 320, and supply given by P minus 8Q equals 20. P is the price and Q is the number of clock radios. Solve the system of equations to find the equilibrium quantity and the price when demand equals supply. So this one wants us to find both. The other one just said break-even quantity, so you only need a quantity. We have two equations. P plus 2Q equals 320, and P minus 8 equals 20. So we could multiply the top by 4 and add down and have it drop, or we can multiply the bottom, just subtract, make it all negative. So I'd have negative P plus 8Q equals a negative 20. The P's drop out. 10Q equals 300. Divide by the 10, Q equals 30. So our quantity, the number of clock radios, would be 30 clock radios. To find the price, you plug it into either equation. I'm going to use the top one. P plus 2 times Q, which was 30, equals 320. P plus 60 equals 320. Subtract the 60. We get 260. And P is the price. So $260, and our quantity would be 30. So that's when we have our equilibrium quantity and price. And that's everything for the section.